What goes hand in hand with multiplying decimals is dividing decimals. And again, we learned so many various ways of how to divide decimals. It goes all the way back to Module 2, and then we picked it back up again when we looked at how decimals relate to fractions. So we're going to look at a couple basic ways of dividing whole numbers and decimals, because really we use the same strategies. For example, if we have the problem 73 divided by 20. If I have equation right here, I can think of this as basic division, and I'm going to just treat this like a standard algorithm equation here. So 73 divided by 20 can be written as 73 divided by 20. And you just go through your division steps. 20 goes into 73 because I know it doesn't go into 7. It goes in 3 times, which gives me 60. So I have 13 as a remainder. Now, as graders, we don't live with remainders anymore. We either need to turn that remainder into a decimal or into a fraction. We learned both ways, and it honestly depends what the problem is asking of you to see which you're going to leave it in. Some answers you get the choice. Some answers only give you decimal or fraction options, so you need to be able to do both. If I wanted to turn this into a fraction, I would keep my whole number as is, and once I finish dropping down my options here, I end up with 13, so it would be 13 over 20. Remember, it's your remainder over your divisor. If you wanted to keep dividing, because this does not have a decimal, I would add a decimal and add my 0. Because remember, 73 is the same thing as 73.0. Once you add your 0, you can drop it down and go through the division steps again. 20 goes into 130 now, which is going to be 6 times, which is 120. Gives me 10 as my remainder. Again, I don't have a 0 down here, so I'm going to add another 0 here, drop it down. Again, I'm not changing the value of 73 at all. I'm just adding zeros to the decimal place, which will let me get a full final answer, because 20 goes into 100 5 times, and that goes in nice and even for us. So we end up with 365 as our answer, but we forgot to pull up our decimal. So whenever we are dividing standard algorithm with a decimal, remember it pops back up to the top in just a quick vertical jump. So it's 3.65. That's the standard algorithm way. Now, we also learned to think about division as fractions, because 73 divided by 20 is the exact same thing as saying 73 over 20. Remember, division and fractions are the same because this division sign is the same thing as a fraction bar, right? Your first number always goes on top, your second number goes on the bottom. So now I have 73 divided by 20. I can simplify this by thinking how many 20s go into 73, which is going to be 3 wholes, and then what's left over is 13 20ths, which was exactly what we got here when we standard algorithm did, right? We had 3 wholes and we had a remainder of 13. So we talked about how you could leave that as a fraction. Looking at these and comparing those, you might think, hey, fraction way is a lot easier. It was a lot less steps, which is super true for this problem. So that's great that you can fall back into going with your fraction method. You're going to use those same steps no matter what kind of numbers you see. These are both 2 whole numbers, but when you get something like 4.13 divided by 19, we're going to follow those same patterns. Again, your options are either thinking of them as fractions or thinking of them as standard algorithm. When you get numbers, though, with decimals in them, you have to think, if you're going to think as fractions, your first number goes on top, 4.13 over your second number, so it's 4.13 over 19. It's not as clear and simple here because you still have a decimal. So we looked at how can you get rid of that decimal, right? How can I think of 4.13 without a decimal? And you can just multiply that by a number. Because this 3 is in the hundredths place, I can multiply this by 100, and it will cause that 3 to move over 2 places. So multiplying it by 100 will give me 413, no longer having a decimal. Now, the rule with fractions is whatever you do the numerator, you have to do the denominator. So 4.13 times 100 is the same as the numerator option. You still needed to 19 times 100. 19 times 100 is going to end up giving you 1,900. So now you have a division expression of 413 divided by 1,900, which you can simplify, which you can divide and get your final answer. If you did not want to go the fraction route with this, you could have again treated it like a standard algorithm equation and done 4.13 divided by 19. And you'd have just gone through your steps. 19 does not go into 4. 19 can go into 41, probably 2 times. And we would check over here. 19 times 2 is 38. Gives us a 3. We bring down our 3, get 33. It's only going to be able to go in 1 time. So we get 14. So this could either be 21 and 14/19, or we could keep bringing down some zeros and seeing if we can get a full answer here. When you divide, though, just like we remembered, we had to bring our decimal up. We still have to bring our decimal up. And this time, the decimal is already given to us here. So we would plop that decimal up, and we would get 0.21, etc. Whatever we get is our final answer. So the main takeaway here is you can either divide decimals and whole numbers by going into that standard algorithm, or you can treat them as fractions. Sometimes you might have numbers that fit one way or the other a little easier. Like if you have the problem 3.2 divided by 0.08. You might see that there's a relationship between 3.2 or 3, I can think of that as 32 almost, and 8. So that should be a basic fact. So instead of doing the standard algorithm, I'm going to treat these as a fraction and say 3.2 over 0.08. And just like before, we need to get rid of those decimals. So to get rid of the decimal here, I'd only have to multiply by 10, turn it into 32. But down here, to turn this 8 into a whole number, I'd have to multiply it by 100. So that means I end up multiplying them both by 100. So the bottom is 8. This top is going to be 320. 320. So I have 320 divided by 8. You might see the fact that goes in here evenly. You might have to do that division, but we end up with 40 as our answer. So we took a division expression with decimals and turned it into a fraction expression to get our answer here. If you had been uncomfortable with that, you could have tried it this way. But then you end up with decimals dividing into decimals, and it gets complicated. So when you have 2 decimal numbers, the easiest way for us to do it is to turn them into a fraction like we did here. If you just have 1 decimal number, you can try it with the standard algorithm or turn it into a fraction, whatever you're the most comfortable with. But again, there's lots of ways that you can divide, and I want you to play around with the different options and really pick the way that works best for you and works best for you in that specific problem. So again, if you see numbers that easily go into each other, you might want to do a fraction method. If you see numbers that don't easily go into each other, doing the fraction method doesn't really help you out very much because you still end up with a weird number that you're going to have to divide anyways. If I had done 4.13 divided by 19 and gotten to 413 over 1,900, I would still have to do division to simplify it. Right? It's some interesting numbers that don't easily go into each other. So I probably would have honestly gone right to the standard algorithm equation for this one. But it's all about figuring out what works best for you and that specific problem when you divide decimals, whether it be the standard algorithm or the fraction model.